Okay, good, there it is. Alright, hey Brecken, so I gave them, your classmates, a sample of the format. I'll email it to you later so that way you can see it with your investigation plan, how it's supposed to look. So I'm going to walk them through it with the format, with the investigation plan, and to go through to see how to exactly do it. Today's more of like an in-class workshop. Some of you might remember it more from last year. We couldn't do it for the year before because we couldn't do it a whole lot last year because coronavirus ruined everything. But we can go through it and practice it again. Alright, so look in your investigation plan book. I believe it's page 85. It says the revised draft at the top. So flip over in your investigation plan, your STEM book. Alright, it's page number, 85. So you're going to tear that one out because you're going to use that one to kind of evaluate your own paper. So it's the same one as I typically use, but it says revised draft at the top. So go ahead and tear it out. If it says investigation plan grade form, do not tear that one out. It's the next one. Don't tear that one. That is from the revised one. Alright, so flip back in your textbook up to the sample on page 35. Have your paper out and the investigation plan and the revised form deck sheet so that we can go over all of it together for it. Alright, so first off, with the format, what type of spacing did you have throughout your entire paper, Noah? Double space. So keep in mind you want to have that throughout the entire thing except for the title page. What is the title page supposed to have, Kendall?
The title page?
Yeah, the title page is supposed to have what type of spacing?
Single.
It's supposed to have single space throughout. Alright, Brecken, I'm going to make the screen focus on the computer screen. I know it doesn't show up super well, but listen and then you come back and ask me questions whenever you feel better to come back to school as well. But I'm going to go sit down at my computer so I can show them how to fix all the formatting. Alright, so in case you don't know how to do this or what to do, how to do it for it, what you're going to do is you'll notice that, you'll notice for the title page has what as the title, Maddie? Investigation plan. Now keep in mind, is everything capitalized on the title page, Kendall?
Yeah.
Yeah, so everything is capitalized on the title page. Remember, it's your name, the date, the teacher's name, which my name is what, Audrey? Thank you. I was Mrs. Moretz yesterday. So just make sure that I am Miss Morse or Ms. Either one's fine. I don't care. That's okay. I'm still not married, so still not Mrs. So still Miss Ms. Morse. Alright, so this class, what is this class, Kendall? Physical science. No one has written biology on it yet, so that's good. Make sure it's physical science and not last year's classes or earth and space science. So no one's done that yet, but just make sure you're not doing it. Alright, so flip over to page 35 with the actual investigation plan and body for it. Alright, notice, now for me, I just grabbed everything at once so that way I can fix all the formatting at the same time. You go over into your paragraph settings, you set this to double, and then you turn off the after spacing. Some of you are having weird gaps kind of in your spaces for it, and that's probably the reason why. I think this automatically turns on to 0.6. So you want to go in and turn it off. So I'm going to turn on the marks for it so you can see it a little bit easier. So you'll notice I have one blank line here, and that's what I was talking about. I want to have one blank line between the sections, because if you don't have that blank line, it gets a little bit hard to read after a while. So that's the reason why I just want just one blank line. So if you just press enter, you're going to get that one natural blank line for it. But for some of you, if you have after spacing turned on, it makes it have a larger gap there. So if you go into the paragraph settings, you turn on the after spacing, you'll notice that it jumps down a little bit farther. And so because of that, you don't want to have on the after spacing because it makes it to have these awkwardly large gaps in between your paragraphs. So that's the reason why you want to go back in and make sure you turn it off. So that way you don't have any after spacing, you're just keeping a pure double space throughout the whole thing. Alright, anyone have any questions about how to do that or set that up? I think most of you have been in Mr. Nadaski's computer apps class, or you've been in it, or you're in it now. So I think most of you understand how to do that. Does anyone have any questions about that? Alright, so your font is Times New Roman. It has to be in the 12-point font. Anyone have any questions about how to adjust that for your whole paper? I think most of you already understand it. 1-inch margins. If you don't know how to do margins, you go over to page layout, margins. You click. At least for mine, I have normal margins, so it's 1 inch all the way around. You can always go in and set it customly, so that's what I do for it. And then you're going to have a 1/2 inch indent. Alright, so if you're going to indent, Noah, what are you going to do? You just do that and it fixes it? I wish that's how it worked.
It's right here, and then you make it go here.
Alright, so what I typically do click the front of your paragraph, you can grab the indentation marker at the top of the page. I think some of you try to do like 3 spaces or 5 spaces or something like that at the front. So if you grab it, you can change up the indentation of your paragraphs. So you can drag it and make it 1 inch. You can make it really short, but I want ½ inch for it. So look up, some of you, I wrote on you, check your indentation. That's where or check indent. So I want it to be at that ½ point mark. All right. No after spacing, 1 blank line between the sections, 1 inch margin. No page numbers in the body of it because it messes up your spacing. You can put it down here in the footer if you want to, but again, I don't require it, so if you don't want to, it's also fine. Alright, anyone have any questions about the format over how to set it up or what to do for it? So again, you can literally take the paper that I gave you, put it on top of your paper and see, okay, as long as everything matches up, good to go. Alright, now I'm moving on from it. Alright, anyone have any questions about that? Alright, I'm just going to leave that up for now. Alright, so looking at the check sheet next to your investigation plan, you'll notice the very first thing is the problem. You want to make it as specific as you can for it. So, Maddie, give me an example of your problem. Sure. Yeah, so for that one, that's a clear question that you're asking. Don't be something specific like, does gravity still apply, or does the straw, or does this affect something else? You want to make sure and pick a clear cut. Look at between this thing, and this thing. Because most of you are comparing substances. The saying is in between these 3 things, or 5 things, or between different effects or something, which one causes a significant change for it. So that's what it's talking about. That you want to get to where you're having it specific enough. Alright, hypothesis. You have to state a reason for the hypothesis you chose. So a lot of you thought through already, and that's okay, but you want to state a reason for your hypothesis. Now remember, what's your hypothesis, Kendall? Yes, what your educator did guess. So what's your hypothesis?
You want me to just repeat?
Yeah.
My hypothesis is that the largest magnet will have the stronger magnetic force as well as the strongest magnetic attraction.
Alright, so you're looking at it with the idea of magnet size, and you're also looking at it to see how far it gets pushed away from the wall in regards to weight, right? So you actually have 2 different ones. Did you come up with your second hypothesis? So read your hypothesis again to make sure it's got both of them.
My hypothesis is that the largest magnet will have a stronger magnetic force as well as the strongest magnetic attraction.
Okay, that works for it. You could have split it up into 2 sentences since you technically have 2 separate experiments going on, but that sounds like that covers both. Again, I'm not entirely sure since I didn't read your whole revised draft, but it sounds like you got both at the same time for it. Alright, so why do you think that? What's your reason for it? You can read your paper, it's fine. You didn't have a reason for why you chose it? Alright, but why do you think that it's the large magnet?
Because the size affects the ability.
Alright, so if it's a larger magnet, what does it have more of?
Magnetic force.
Okay, yeah, more electrons specifically, because you're going to talk about, we haven't learned this yet in this class, but it's the electrons that are actually causing magnetism. That's the best theory currently. Because that is actually still just a theory. We're not entirely sure what causes magnetism as a side note. And so because of that, they're saying, okay, if you have more electrons, then you should in theory have a stronger magnetic force. So that would be a reason for the first one. For the second one, you're putting a heavier magnet on a movable object. So it'll be interesting to see, is there a point where the magnet's too heavy to even move the object anymore at that point? So you might have to think of, and you might have to give that one in 2 sentences, because I don't think you can fit it all in 1 sentence, but that's okay, and that's okay for it. So since your reason has 2 sentences, you might want to split up your first sentence into saying, okay, here's my hypothesis, and for my first part of my experiment, here's the hypothesis for the second part of my experiment. So that might help it out a little bit. Alright, anyone have any questions about yours after hearing that explanation? Alright. So, experimental procedure. How many independent variables should your experiment have, Noah?
5.
Let's say, we're in trouble, Noah. I think I need to see your paper after all. Give it to me. Alright, so, you have 1 independent variable. I will cry. So, 1 independent variable. That's that 1 difference. What's your 1 difference, Noah? Oh, no. It's okay. I feel like this day to take a while. It should be like your shapes, isn't it? That's what you're building, different shapes.
I'm so concerned.
Alright, so you're building different shapes. What's the shapes you're building now?
Pentagon,
Okay.
triangle,
Okay.
square,
Okay. Yay. Okay. What are you building them out of?
wood,
That's gonna be a very sturdy structure. You might want to use popsicle, at least for the first couple of times, unless they collapse way too. How much weight are you putting on them?
I don't know. I mean,
A little bit concerned again. Alright, so, because again, I had someone build, that can go up now. I had someone, they built their structures one year. I think they built it out of bricks, so that way, like, none of them collapse. So don't do that, because you have to be able to test it. But I don't think they had enough weight to, like, test to see, like, which one collapses first, because they built them so sturdy the first time. So you might want to do it with popsicle sticks and, like, marshmallows, because again, what? Wood!
Popsicle sticks are wood.
Yeah, like chunks of wood, like plywood. You're gonna go out and get like a power saw and cut it up. Okay, because popsicle sticks and what's your construction? Like, what are you gluing it with?
Glue.
Okay, so that works. So just making sure though that you use the same amount of glue for each one. Don't decide, okay, this one gets a little bit of glue. This one, it's gonna stick. So make sure you use the same amount of glue because that'll be another independent variable. So come up with a way to make sure you get the same amount of glue on each one. You don't want to rig it so that way one collapses easier than another one. No cheating. This one gets L-marginal glue. This one gets rubber cement. So make sure you think it through so you're not cheating in it. Okay, so. Alright, so that's one independent variable with the idea of it's the different shapes. That's what you're testing for. Do you have a control group?
What is that?
Okay. Alright, so what's a control group, Maddie?
It's like the different things. Like, I don't really know. I just said there wasn't one.
Alright, Gavin, what's a control group?
That's hard to like say. It's like we can compare something.
Alright, so between the experimental groups and the control group, what's happening?
Yeah, comparing ones. Better.
Okay, so control group's the normal one?
Sure.
Yeah, so the idea of it doesn't have that one independent variable. You need to say somewhere in your paper if there is no control group. Some of you might remember this goes on your board later on. So how come you want to say now of there is no control in my control group. I don't think anyone has a control. Did you end up getting one, Laundry, for yours? Okay, so for yours, because you're testing to see insulated materials, that's a couple of I wrote in yours. It might be interesting to actually have a control group because you're testing to see how well this insulated material works. And you don't want to go and be like, okay, this one's the best, but it's still pretty lame. So it might be interesting to see, okay, this is how much it insulates, but is it actually really good compared to a normal jar? So that's why for yours, it'll bring it to the next level if you just use a regular jar with it to see how much does a normal jar use compared to your bubble wrap, newspaper, sock. I don't remember the last one.
Sock.
Sock. I don't remember the last one. Was that it?
Somewhere in my paper. Oh, bubble wrap.
Okay, bubble wrap. So it might be good for you to didn't have a control group for yours. I think you're the only one that I wrote that on. I don't remember if I told anybody else, but for you, since you're comparing, saying which one works the best for an insulator, it might be good to see this is what a normal uninsulated jar looks like. Alright, does that make sense? Alright, does anyone else have a question? I don't think anyone else had a control group. Anyone else have a control group? I don't think anyone else has it this year in this class. Alright, so say if you don't have one, so if you decide that you want to have one, I think it'd be really good on your fingers. I'm not telling you to, but I think it'd be really good. So, just make it up for it. Alright, so your variable, that's your one independent variable. So, you want to describe it details as much as you can, because if you look at the grade form, flip back, I'm going to make you flip back and forth, I'm sorry. So, if you look on page 87, you'll notice clear variable, everything else held constant, and that's worth 7 points. So, it's pretty much an all or nothing. So, if I can find out that you haven't thought through everything, or there's enough differences to where it makes me worry, to where I'm worried that where you don't have that clear independent variable, I'm gonna go ahead and dock you points now because that clear independent variable on the test grade in the spring is worth about 10 points. So that's why it's only worth 7 now, telling you fix it now. So if you don't fix it now, I don't want you to get docked again in the spring because you didn't fix it. That's why it's worth a lot now. So give me as much information as possible to show me you've got through everything and there's no mistakes. That's happened a couple of times where like students, they said, I've thought through everything and I'm gonna do it great. And then they actually start doing it and I start asking them questions about it and then I realize, no, you have 2 independent variables. And now their experiment is ruined and they've lost basically a whole letter grade because of it. So that's another reason why they have to think through everything now. Try to give me as much as you can. Don't just say, I'm gonna think through everything. That's a nice disclaimer sentence, but you need to actually show me. Don't just write, I will make everything the same. Well, no, I need to make sure you thought through everything, because if I discover it with your experiment that you haven't, that's whenever you're going to lose major points later on. Alright, anyone have any questions about that? Alright, so looking back over on the investigation, the check sheet one, your book points out you need to have the number of trials. How many times did you test each part of your experiment, Kendall? 3. So you have to compare a minimum of 3 things, which I think for most people in this class it's fine. Your experiments are detailed enough to where doing it 3 things is fine. Sometimes for junior high, depending on what they're doing, I ask them to do 5 because they're learning how to do an experiment, and sometimes their experiments are a little bit oversimplified. Sometimes it's helpful to have more than that. That's a nice way of putting it. But I think all of yours are advanced enough to where it seems like you're good to go with just 3 things. Alright, so number of trials. So for Noah, what are you going to do for you? Because you're supposedly breaking down your shapes every single time.
For what?
What's your experiment, Noah?
Building shapes.
Okay, so once you build your shapes, what are you going to do? You can't just go, ta-da, shape, build.
Put weight on it.
Okay, so what happens if you're going to put weight on it?
It's gonna break.
Okay, so how many of each shape should you build probably then?
3.
Okay, so if you have 3 shapes and you're building each shape 3 times, how many total shapes are you going to have? It is late in the afternoon.
9.
9, good job. So you need a plan to build. Okay, I'm going to build 3 pentagons, I'm going to build 3 triangles, I'm going to build 3 rectangles. So if you want to build them all in one day, that's fine for it because if everything goes according to plan, you're going to have splintered remains of your first couple of shapes. If you want to build more of them to test them, or if you realize, I think I messed up, but I'm going to build some extra, then that might help you. Or if you want to just yeet them off the side of the house later, you can also do that as well. Alright, so anyone have any questions about that? Alright, so anyone have any questions about the experimental design section? Alright, measurement technique. Describe the specific way you will you will measure the result of each experiment. And so you have to use what type of units? Metric. I believe I wrote on your papers for all of you telling you what the different type of unit is for magnetism. So does anyone have any questions of, not different types of units for magnetism. I'll think about yours specifically in a moment. But you're doing yours in length to see how far it travels, right?
Mm-hmm.
So what's the metric unit for length? That's a very long time the magnet's going to be going. It's going to a meter. All the way across. What are you probably going to be using it in? What's the next stage down typically in a meter that we use?
Inch or centimeter?
Centimeter, about to say an inch is not part of a meter. Inch is part of a yard. But yeah, so a centimeter is probably what you measure it in. That's probably my best guess. Maybe millimeter, maybe, but probably a centimeter. Alright, Noah, did you figure out what units you're using for yours? Okay, so if you're using metric units, you're doing weight in the metric system is a little bit weird, and so because of that, you can probably use mass and get away with it because weight has to do with gravity. Your gravity should not be changing in your experiment. If you do, you're doing something weird. So your gravity is probably the same. So if you say how much mass can it support, you're probably still okay. So what's the metric unit for mass? G.
Grams.
Good job. So you probably want to use grams. Maybe kilograms depending on how squash you want them to get right away. But probably grams, probably what you'll at least start off with and then decide grams. Kilograms is where I'm going. Alright, you're doing dead ants. There's no units for dead ants. So County, are you doing time? Okay. So time, you could maybe seconds, maybe minutes for it. But again, did you understand what I wrote about not using the same ant about not releasing them into the wild? So if ant survives your experiment, you still can't release him into the wild because your ant will smell entirely different and his buddies will no longer recognize him as their friend anymore and he'll die sad and alone. So go ahead and just kill him. Just know every ant you use is dead because he'll either die immediately or you will murder him. So just make sure that I would not release him back out into the wild. He'll lead a sad, lonely, confused life of starvation. So just let him go. What? Just send him on to heaven. It's gonna be ant heaven.
It's gonna be whole.
Just kill him. Alright. So Andre, I don't remember what year you're doing heat, so did you figure out what you're doing for that one?
I don't know what formula I'm using.
Didn't you write on the side that you're using because you're using temperature change, right?
Mm-hmm.
Alright, and so you're working with water. What's specific heat of water?
Isn't it Q?
No, that's the formula. You're right. So Q equals.
C delta T.
Alright, so what's the specific heat of water? Do you remember? You know. Okay. So 4.18 joules, I believe, per gram degree Celsius. What's the mass of the water you're using with?
You mean like how much water I'm
Mhm.
putting in? 6 ounces.
Okay, you're gonna have to convert that one to grams. I know there's conversion units you can use online for that one. I don't remember what 6 ounces is in comparative water, but if you're gonna use this formula, it does have to be in grams. And then temperature change. So at least that one will be straightforward with the idea of if it goes from, you're starting off in boiling water, right? So if it goes from, so if it's boiling, what's the temperature of the water?
100.
Yeah, so if it goes from 100 to 96, how much of a temperature change is that? 4 degrees. So keep in mind for this one, you're going to probably, are you doing how much heat it's lost or just, okay, so this one is a negative number, you're gonna get a negative number for Q as well, but that's okay, because you're saying, okay, it's negative energy is lost there. Alright, so if you're using this formula, you're gonna have to use it in grams, just make sure, and you go online to a conversion factor, that's probably the best way to do that. Alright, thanks for everyone except for Maddie. Alright, Maddie, do you know what your measurement units are? Sorry, what? Oh, okay, that's right, because you're working with how long, are you using a flashlight or a light bulb?
Do you know the string with white lights in it? I might use it better than when I turn them off.
Yes.
Yep, this one.
This might take several days, as a side note. Okay, so keep in mind though, you want to watch it. Do you know how long loosely the batteries are supposed to last? You might be here till next Christmas, so as a side note, just keep in mind that it might be, you might get to like, oh, it's not the point if you leave them in there for like 24 hours straight, just trying to burn through them, because it depends on how strong your battery is, how much, you probably want to look at to see maybe watts of the individual string of lights, which they don't have a lot of watts, so it's going to be slowly beating them up. So just check to maybe see how long it's going to take. You might discover you might have to switch over to something else that has more power halfway through to actually start draining the batteries. Figure out how fast this actually is. So just be aware of that. So you're doing hours for yours. Alright, did you think through over how you're gonna actually measure whenever the light starts to fade, or are you gonna say whenever it completely cuts out? No light whatsoever? It is dead. Okay, so that's fine. But just make sure that might take a while. You might be here a while. So just keep that in mind that it might start making, so if it's week 2 and you're still going on Duracell, it's time to be a little concerned. It's time to start getting worried. Alright, so anyone have any questions about that? Alright, describe the method of graphing the results. So, I think I wrote that in pretty much everyone's paper, that the example says to start thinking through how you're going to actually graph it. So you have the y-axis and the x-axis. The y-axis is the up and down one. The x-axis is the back and forth one. So if you're doing a graph for light bulbs over time, what you'll, or light bulbs over like a longer period of time, you probably wanna do time on the side. You're probably going to do the light bulbs down here at the bottom. Or technically, you're doing with batteries, technically for it. So this will be battery number 1, battery number 2, battery number 3, battery number 4. If you get bored and I'm wrong, you start burning out really fast. So battery number 4. So for this one, you say, okay, this one lasts 2 days, 1.5 days, 5 days, half a day was a rip-off. And so it might be something where, okay, you want to plot it out that way. So the x-axis is typically your type of whatever it is, like types of magnet size, types of solution for poison and death, types of shapes. So that's what the bottom typically is. While the Y one is typically your measurements, like your time or the distance or amount of heat loss, something along those lines. Alright, anyone have any questions about that? Alright, back page. So you should test 3 things each, 3 times each, but how many independent variables, Noah, should you have?
1.
Yay, good, just making sure. Alright, conclusion. State the standard or measurement change and that you'll use to decide if your hypothesis is true. I did not require a measurement change because that gets too nitpicky too fast. It's basically saying how do you know if you're right or not. How do you know if you're right, Maddie, for your hypothesis? Okay, so which one did you predict would last the longest? Alright, so your hypothesis is I predict Energizer will last the longest, something along those lines, right? So your conclusion says what then? Good job, that sounds pretty much perfect. So that's the idea of, okay, how will you know if you're right? So what's your conclusion, Noah?
If the pentagon out of all 3 of my shapes holds the most mass, my hypothesis will be correct.
Did you predict that the pentagon would hold the most mass? Good. Alright, so does anyone have any questions about your conclusion? It may only be like 1 sentence, and that's okay, and that's normal. Alright, anyone have any questions about that? Alright, safety. Alright, look at their sample for the safety really quick. I know it's indented. I did not take off points for this, and I won't take off points for this. But if you look at their sample, you'll notice that they indented the first part of their paragraph still. It looks weird whenever it's in a list and you indent the first one. So please don't. And that's not how I wrote that on some of your papers, so please don't do that. I'm not going to take off points for it because that's what they did. But please don't do that because it just makes it look funky whenever you do it. It causes people to go, what are they doing? So, if you're going to do it in a list like that, please keep them all straight. Alright, anyone have any questions though about that? I think everyone's safety was pretty straightforward. Try not to be excessively silly with it. I had to talk to junior high about that because they were going through I will not cause people to die. Okay, so try not, okay, we understand you should not cause people to die. But try not to be excessively silly. So again, think through, okay, is my particularly really actually dangerous? Like Gavin's is actually potentially really dangerous, so careful of yours. Okay, the batteries are probably not that dangerous unless you catch the house on fire. But I mean, you're probably gonna be fine. Magnets again, probably fine. I feel like everything's potentially dangerous with you. So be careful for it. And then yours is working with hot water, so you have a couple of other safety features for yours as well. Alright, anyone have any questions about the safety ones? Alright, so that's pretty much it. Check your format, check your independent variable, make sure you only have 1, otherwise you'll take out points for it. Alright, the final draft of this paper is due not tomorrow, not next Friday, because of the holiday, but the following Friday. So it's December 4th. So you come back on Monday, and I go, hi, welcome back, paper due Friday. So don't forget.
Oh, no.
So that's why I'm telling you now. So if you want to work on it over the holiday, I don't expect you to, okay? I know you're probably going out of town and having fun and you want to yeet the entire paper out the door while you're gone. Okay, I understand. But I'm just saying, for right now, if you want to, don't be surprised whenever you walk back Monday morning. Hello, welcome back. Did you have fun on Thanksgiving? Paper. So just make sure that you're thinking it through and that you don't forget. I'll probably email your parents today to remind them today or tomorrow to let them know as well. So it's not shocked whenever they come back as well. Paper. So be sure to be thinking over it. So it's due not tomorrow, not next Friday, but the Friday afterwards. Keep in mind this counts as 2 quizzes because it's super important. So this one counts twice. So make sure that you're thinking of it and don't just decide I'm gonna wing it Thursday night. Please don't. It's bad. It makes me unhappy when I have to give people bad grades for this because I need to fix it before they actually start doing the project. So make sure you think through everything as much as you can. Alright, anyone have any questions about this? Alright, so let's get into it with your actual textbook now. We're talking about biochemistry. We're in biochemistry. What are we learning about, Maddie? What? Biochemistry, good job. So, you think we were talking about cell processes and what your cells need to survive. So, we talked about sugars. Sugars is the common name for what type of nutrient, Audrey? What? Carbohydrates is correct. I thought you said something else entirely different for a second. That's your real concern. Yeah, so your carbohydrates, so that's your example. We talked about the hydrocarbons yesterday as well. So this is kind of like a recap, thinking about hydrocarbons. If you're a hydrocarbon, what type of molecules do you have, Noah? Yay, and? Good job. What's the study of hydrocarbons? Kendall? Good job, organic chemistry. So if you have just single bonds, what type of hydrocarbon are you? Alkane. Good job. What if you're a double bond? Good job. What if you have a triple bond? Noah? I thought you were just like glaring at me for a second. No, that's not a hard question. It could have been worse. Not an alkane, not an alkene. What's the last one? Alkyne. Good job. Alright, what do you call the ones that are in a circle, Maddie? It does. Yeah. Alright, yeah, what do you call it? The circle ones. Okay, so the aromatic, no, excuse me, do not say aromatic, that's the wrong term. The hydrocarbons in a circle. Okay, think of it like this. So, describe a bicycle.
You need that. You just say hydrocarbons in a circle. My brain's not thinking.
It is a hydrocarbon in a circle.
Yeah.
Describe a bicycle. What? Oh, I'm back to bicycle now. What is bicycle? Okay, describe a bicycle.
Metal object.
Okay, with
Tires.
alright, how many?
2.
Alright, what shape is the tire?
Circle.
Yay! So that's why it's bicycle. So the cyclic or cyclic, that's for the shape of virtue. So it's the idea of it's the circular hydrocarbons. So make a note for that. So circular hydrocarbons or the cyclic hydrocarbons, make a note for them. Alright, what do you call the ones that are delocalized now? Noah. It's not on purpose, but sometimes it is. Did I? Oh, I did. I did earlier. Yeah. Not right away. I only go the last 30 seconds. So if you do like the instant replay in your head over what I said, I didn't say it close enough. You can only do that in about the last 10 seconds.
I can't even remember what people say in the last 10 seconds.
Alright, so what type of compound is it? The hydrocarbons, whenever it's the cyclic ones or the circles, but they're delocalized electrons. Anyone remember? A. Yeah, these are the aromatic ones. This might be what you're thinking of a minute ago. So the aromatic hydrocarbons. Alright, what do we call the, what do we call the hydrocarbons to where they're not the normal ones? Something has been changed about them. What do we call that, Kendall? S. So it's not your normal teacher. What do we call someone that's still a teacher but it's not your normal teacher? Okay, so this is a hydrocarbon, so close enough. Substituted hydrocarbon. Alright, what do we call the part that's actually taken off, or you have another section put on? What do you call the part that's actually being changed? The alcohol is the type of this. Functional group. So that's the idea of a functional group. Alright, what do you call the ones that have a halogen hooked onto it instead? Maddie. H. Alright, so it has call that, Gavin?
Alkane.
Haloalkanes. Make it up that haloalkanes. What do you call it if it has the OH functional group, Noah?
What's
A.
the
Wait, no, it's not that weird one. Or is it? It's the weird one.
I don't think so. Maybe? Maybe.
Really long one.
Maybe. Oh, no, not that.
alcohol?
Alcohol!
Yeah, it's not
So
the
look at
weird
that.
one.
It's the LH. It has hydroxyl about it. What is the one that has the COOH hooked onto it? This is probably what you're thinking of, Gavin. So it's the C. This one. What do we call? What do we call that one? Scandalstrom.
Start with a C.
It does.
Carbobox.
What?
Okay, partly.
Something.
Alright, Audrey, finish it up for us.
Carboboxyl.
Okay. Carboxylic acid. Carboxylic acid. So
I
please
didn't
don't.
know that one.
What?
Oh.
You used it. You knew that one, or you didn't?
Yeah, I think I'm getting it.
Yeah, but yeah, so carboxylic acid. So please don't write carbo something acid. Okay, carboxylic acid. Alright, what is the one to where it loses the H and then we hook it onto the chain again? Noah.
Starts with an E.
Yeah, I was about to say.
It is an ester. Alright. Alright, what do you call the type of molecule that has a polar end and a non-polar end? We need to stab oil. Not really.
Huh?
Yes.
That was scary.
But yeah, so it sticks to it. So what's it called? So what do we call the type of soap molecules we use today? Technically, so that way they don't interact with hard water. Gavin? Detergent. Hard water. Ice. Not really. Just kidding. It has ions on the inside of it. So sometimes they'll have things like calcium on the inside of it. So that's what comes to react to make kind of like this chalk stuff in like old hot water heaters. Alright, so what do we call a long chain of molecules hooked up together? Kendall. What is the type of plastic? You're probably wearing this.
What?
You're probably wearing the type of this. It starts with a P. Alright, do you remember, Gavin? See, I think you're cheating. Alright, what do you call it?
Polysaccharide.
Okay, that's sugar specifically. So polymer is what I was thinking of. So polymer, that's whenever it's a long
Close enough.
chain hooked together as simpler unit. So you're right that poly means many. So polysaccharide is a long chain of sugar. Alright, it's made up of those monomers, those monomers. What do we call the process of making a polymer? Because you're gonna break those double bonds and you're gonna hook on extra hydrogen to it typically. Alright, Maddie. P. Alright, Kendall. So to make a polymer, it starts with P.
Actually, that's not that hard.
Look, Gavin.
Yeah, I'm just what direction look at you're like, yeah, it's actually not that bad.
You make look, Kendall.
Oh, my head.
Next page. I think you're on the right one.
Top of the page.
Yeah, that's
Polymerization.
Good enough. So polymerization is how your book says it, but yeah, it looks like polymerization. Alright. I think that's the last one we got onto yesterday. So biochemistry. Alright, simple carbohydrates or sugar. So monosaccharides. What's an example of the monosaccharide we talked about yesterday? Audrey.
Sugar.
It's the example of it. Because whenever you say sugar, you probably mean table sugar, right? Okay, that's a disaccharide. So what's the common example of a monosaccharide? Good job. So where do we get glucose, Noah?
Plants.
Alright, how do they make it?
Light.
What's the process called, Noah?
Sun.
What's the process called?
Photosynthesis.
So it says, good job. Alright, what do you call a long chain of sugars hooked up together? Gavin said it earlier.
Don't remember.
She doesn't listen to you, Gavin. Alright, Gavin. What's it called?
polysaccharide.
Polysaccharides. Now in people, we call that just starch, or and more of an excuse me, in plants it starch, and people is more of glycogen. That's how we sort of. I was like, wait a minute, wrong thing, wrong chain, wrong chain. People do not have starch on the inside of their bodies. Wrong thing. Excuse me. No. Alright, so starch in plants, glucogen in people. Alright, what is the indigestible polysaccharide that we still eat to clean out your intestines though? Maddie, you be quiet. C or F, either term works. Fiber or cellulose. Make a note for cellulose though is the official term for it. Alright, so fats and fatty acids. So it looks kind of like a tripod. Does anyone still use tripods to take photos or not anymore? Most of the time you can just use like a selfie stick or something like that. Or someone's arm.
I would say that's
That's
a
like
cow.
2010.
Yeah, what is it, Noah?
That's like 2010.
So old, Noah. Alright, so but yeah, typically today you don't use tripods anymore. Your grandparents or someone from 2010 might still use it. But it's the idea of you used to have to stick your camera at the top of it and set a timer and then go run in the front to go take the photo. We don't do that anymore. We don't have to. But this is the idea of it looks kind of like a tripod. So make a note, a lipid though is a group of biological compounds characterized by insolubility in water. So if it's insoluble in water, what does that mean, Noah? Good job, that's all I'm looking for. So it cannot be dissolved for it. So the simplest type of a lipid molecule is called a fatty acid. A fat molecule is made up of 3 fatty acids hooked up together. So the terms are very similar. So you have a lipid, and then a type of lipid is the fatty acids, and then you have 3 fatty acids hooked up together, you make a fat molecule. That's what this is. This is a fat molecule, not like the idea of like how you think of a fat molecule. It just means, okay, that you have 3 fatty acids hooked up together. Alright, anyone have any questions about that? I'm sorry. Alright, so your books are going into saturated and unsaturated fats again. Some of you might remember this from health or from junior high life science. What's the difference between a saturated and unsaturated fatty acid? So sorry, Audrey. Alright, so think of it from with the number of hydrogen. Which one is full up of as much hydrogen as possible? The saturated or the unsaturated one? Take a stab at it, Manny. Okay, saturated or unsaturated? 50-50, Manny. Which one is full of as many hydrogen as possible? Good guess. So, saturated. So if you have a saturated sponge of water, what does that mean? No. Bracken can hear you better than I can. Alright. So, you have a saturated sponge, not SpongeBob. What is it? How would you describe it if you were sticking in water and it becomes saturated? I know it's rude now. Okay, so what do we call it? How would you describe it? Yeah, so it can't hold anymore. Basically, you pick it up, it's gonna be all like squishy and drippy. Now, this is a really weird example now. Okay, let's say if it can't hold any more water. So let's say you have saturated fat, that it can't hold any more hydrogen. It's as full of as possible. These are typically a solid at room temperature. So how many of you, your parents cook with lard or Crisco? It's that white pasty stuff in the cabinet. I don't even want to know. Alright, so this stuff is typically, it's kind of like, it has kind of like a weird, or if you've ever cooked with, or if you've ever watched your parents or your mom cook bacon, your entire class has giggles now. But that's the reason why, if you've ever seen bacon fat, or like fat in like a steak or something, it has kind of like that whitish kind of clear texture to it. Typically you don't eat that because it's kind of gross tasting. Now some cases it tastes really good, but as a general rule you typically don't eat it. That is a type of animal fat, and that's saturated fat typically. So it's typically a solid at room temperature. Unsaturated fat is not full of as hydrogen as it could be, and so because of that it's a liquid at room temperature. We call these oils. So this could be like vegetable oil or canola oil is how your mom uses it. Vegetable oil, olive oil. Your book points out some of those examples for it. So yeah, if your mom uses an oil to cook with, it's probably a type of unsaturated fat. Alright, your book points out that if you have just one double bond, because remember the double bond basically allows it to where there's not as many hydrogens, we call it monounsaturated. If it's more than that, it's polyunsaturated. So your book's just pointing out the different ones for it. Alright, your book points out that typically unsaturated fats are better for you. Here's an example of a saturated fat. It's the idea of every single spot is full of hydrogen as much as possible. This one has a double bond, so you could break it and add on an extra hydrogen, add on 2 extra hydrogens. Same thing down here is you could break these bonds and have extra hydrogen hooked onto it. So those are unsaturated. Alright, next page. Alright, sometimes scientists, they want to take oil and make it into a type of substitute like margarine to where they're going to take vegetable oil and basically shove in extra hydrogen to make it solid at room temperature. Because no one wants to put vegetable oil on like toast because that's gross. So they decide we're going to basically make it a little bit thicker. So by doing that, they break up the double bonds and they add on extra hydrogen. That's what margarine typically is inside now. So if you're wondering what's margarine made of, that's typically it. So we call this process hydrogenation. It looks like hydrogenation. Please don't say that. So hydrogenation. Make a note for that. That's the process. That's like that's process, and that's like polymerization, where you're breaking the polymer bonds to add on extra hydrogen. It's the same idea. You're breaking those double bonds to add on extra hydrogen. All right. Anyone have any questions about that? All right. Cholesterol. This is another lipid. All right. What is cholesterol? Okay, cholesterol is a lipid. Your body uses it to make bile and vitamin D, cell membranes, important chemical messengers called hormones. Alright, you should know what a hormone is. What's a hormone? Kendall. What is a hormone? What is it, Gavin? Do you go get tissue or something?
Nah,
Okay.
I just remember why y'all looking at her.
I know, because I saw her immediately look down at her paper like she was avoiding eye contact. That's right, that's Kendall, isn't it? What's a hormone, Kendall?
That's a good question.
Alright, how many did you chance to say this? You were biology last year. Sorry.
Something that was probably remembered.
Okay. Anyone remember what a hormone is? But I know for the rest of the class, it was 2 years ago from life science and you haven't had help yet. Right? Close enough. It's the chemical messengers and that your endocrine system uses. So like your pituitary gland, if that's what you're thinking of for it, that's what it's used for. So these are using your hormones. Your blood that cholesterol is transported through the bloodstream in lipoproteins. These are globules of cholesterol encased in a membrane made of lipids and protein. So it's kind of like the packaging, like whenever you order something on Amazon, you just don't get just the item just dropped off at your door. They put it in a box and then the box comes to your door, which is a good thing that doesn't just awkwardly show up at your house. So they put it in a box. Alright, go for tonight. Alright, read page 185. 2 pages here. See how fast I want to talk on Monday when we come back. Not that fast. No. Alright. Okay, we'll say 185 to 189. We'll probably make it that far. 185 to 189. Alright, answer the questions on page 192 in the section review at the top. Alright, you could do questions. Alright, we'll say just 7 and 8. So just 7 and 8 on page 192.